All right. Today we're going to keep looking at intercept form. We're going to look at how to do basically the opposite of what we did last class. Last class we saw a quadratic function and graphed it on an xy plane, and today we're going to be able to write a quadratic in intercept form given a graph. So we're going to take a graph and try and come up with the function, the equation for it. So here at the top, we see the intercept form of a quadratic. Remember, it's x minus p, x minus q. It's got that flip going on. So if we've got a subtraction sign, p was positive and vice versa. So let's see, the first thing that we're going to be able to do is, well, intercept form is concerned about the x-intercepts. And so if we can spot them on the graph, that gives us our first step. So if I'm looking at this first one, I see some x-intercepts. My x-intercepts being, we've got -8, and we've got -2. Okay. So there's our first step. We were able to identify them. Now I'm going to look for another known point. This is going to be very familiar. This is exactly what we did with vertex form. There's a lot of known points that you can find. For me, the first thing I look for when I'm writing an intercept form is, well, now the vertex is a known point. The vertex becomes a point that we can use if we can see it on a nice crossing. Here it actually is. But you could use any known point. So as you look along this curve, there are definitely some other known points. We got what, 1 and 9 up here as well. That looks pretty good. But I'm going to use the vertex just for right now. So we've got -5, -3. So let's do that. -5, -3. Now remember, this is my P, this is my Q, this is an X and a Y of a known point. Okay. We're going to do the same thing that we did for vertex form. We're going to write out the skeleton. So it's just kind of the standard with just all the variables, nothing plugged in yet. A times X minus P times X minus Q. Boom, just the skeleton. Now the next thing we're going to do is we're going to plug in those x-intercepts for P and for Q. Okay, so we get Y equals A times X. And now we have to think about our sign. P was a negative. It was -8. So if we have X minus P, we have X minus -8, which is really a double negative, which means we really have X plus 8. And this kind of lines up with our little trick. We knew it was going to be opposite. So if we have +8 in our form, the actual intercept is going to be -8. So it's working out really well. Same thing here. We have -2 for Q. And so we actually have -2, which is just the same as +2. Okay. So far we've just plugged those values in. Now we're going to plug in our other known point for X and Y. So let me grab my red pen where we see Y, and in both places that we see X, we're going to plug that known information in. So for Y, I've got -3. We still don't have A, but we do know our X value is -5. We still have the +8. X is -5. We had +2 in this one. And then we'll close it up. Now all we have to do is solve for A. So if we take this, what we've plugged in so far, and start to simplify, we can see -3 equals A times, let's say -5 plus 8 is a +3. -5 plus 2 is a -3. We get -3 equals A times -9. And if we divide both sides by -9, we get 1/3, +1/3. Okay. Now, this is our A value. It's positive and it's less than 1. Let's come back to our graph and see if it makes sense. Positive says a curve up. That looks pretty good. And less than 1 means we're going to have a little bit of a stretch going on, and that looks like exactly what we've got here. So we're confident in our A because of what we know visually should be happening. Finally, last step is we're just going to write down our final form, putting Y and X back, but putting in our A, P, and Q. So we've got x plus 8 and x plus 2. This is the function for our graph. If we plug in any x value that we want now, if we were going to plug in any value for x, we would get a y value out. That's the value in doing this, is taking something visually and being able to get any point calculated out of it. All right, that is the process. If you feel good about that, feel free to go start on the practice worksheet. I am going to do one more example out, but if you're going to move on to the practice, just know that you have the rest of class to complete it. If you don't complete it, it will become homework. So please use your time wisely. If you finish early, just work on any missing homeworks or your cheat sheet for the upcoming tests. Okay, one more example. Let's see what we got. Use the same colors. So let's say P and Q are our x-intercepts. We've got +3 there and +5. And then I'm going to look for a known point. This could be any point. I'm just looking for any crossing that I see happening. In fact, the only one that I do see here is the vertex, so I'll use that again. But again, it could be any one. It almost looks like maybe -11 there would work. It almost looks like that's a known point down there too. So any of those known points will work, but I'm going to focus in on this vertex. That one is at, let's see, +4 and +4. So it's 4, 4. We're going to write out the skeleton form again. Y equals A times x minus P times x minus Q. And then just start plugging stuff in. We start with our P and our Q, being mindful of the sign. So we've got y equals A times x. Let's see, minus P. It was +3, so in fact, we actually stick with that minus sign. And in fact, here I'll do that as black, because P is just 3. It's a +3. And then same thing, we've got x minus Q, which was a +5. So hopefully we can see that connection, that where we see positive numbers, we're going to see subtraction signs, and where we see negative numbers, we're going to see addition signs in the form. From there, we're just going to plug in our known point. Again, in this case, I grabbed the vertex. It doesn't have to be the vertex. Sometimes you can't see where the vertex is landing, but in this case, we were able to. We saw 4. 4 equals A. And we got 4 minus 3 and 4 minus 5. Oh, whoops, I put that in blue there too. All right. All of our plugging in is good. Notice that our only variable left is A, and so that lets us solve for A. So let's see, we have 4 equals A times, let's see, 4 minus 3 is 1. 4 minus 5 is -1. So we have A, 1 times -1 is just -1. And we're going to divide that -1 off on both sides. We find A equals -4. Again, going up to our graph just to check, we said negative, so it's going to curve down. Yep. And A is greater than 1, so we should see a shrink. And we actually do see that. So that looks pretty good. All that's left is just plug that back in. We're going to leave X and Y, plug in the A, P, and Q. We've got X minus 3 and X minus 5. Once again, now this gives us this really powerful thing where we can plug in any X value we want, including fractions, decimals, negatives, wherever we want to look for an X, we can find the Y now. All right, that is 2 examples worked out. Flip back through the video if you need reminders. If not, go back or go onto the practice worksheet and give those a shot. Have a good day. We'll see you on Friday.